Dear students, in this video I'll be discussing on multiplexers. Multiplexer in the short term also called as an MUX. So it is multiple inputs and a single output. When we have a multiple inputs, we are going to choose what to be our output. So that will be done based on the select inputs. So here it's an example for that 2:1 multiplexer. 2 inputs and 1 output. So how many select inputs will be having? 1 select inputs. So there is a formula which defines the relation between this number of inputs and the select inputs. 2 power n inputs, n select inputs and 1 output. That is how these multiplexers are. So 2 power 1 means 1 select inputs. So 2 inputs and 1 output. If 2 square means 2 select inputs, 2 square means 4 inputs. So 4 inputs, 2 select input and 1 output. That is how we are going to find the relation between the number of inputs and the number of select inputs in the multiplexer. So then the examples of that has been given here. So 4:1 MUX. So 4 inputs, 2 select inputs. What if it is 8 inputs? Then 3 select inputs. So 3 select inputs and 8 inputs and 1 output. So the number of inputs and the outputs, this is what the ratio is. So the relation n control inputs, 2 power n data inputs and 1 output. This control inputs also called as in select inputs. So how it is exactly designed here, it's just like a switch. So we are just connecting either this input to be our output or this input to be our output. So how we are going to design that, which one to be here, that decides by this control input. If my control input is 0, then I0 bit will be chosen as an output. Whatever the content is flowing in I0 will be flowing across our output. If this select input is 1, whatever the content of I1 will be chosen as our output. So I1 will be connected to this Z. That is how this will be working. Internally, it's working like a switch. So that's what has been shown here. Suppose when we want to design this multiplexer, how we are going to design when we are choosing Z. So you need to write the truth table for the 2 inputs. When there are 2 inputs, 0001, 1011 combination. So when we write that, then how many outputs, that we are going to do it, right? But here these 2 inputs, we are not doing any activity over here. We are just driving this input to be as an output. So now the major inputs are considered like the select inputs, because this is the one which is deciding what to be our output. So there is a possibility here it can be 0, 1, right? So that's the reason Z is equal to this output. Z is equal to this A select input has been named here as A. So if A is 0 means A bar, then I0 will be our output. Plus if A is 1, then I1 will be our output. So that's what been written here. Z is equal to A bar I0 plus A I1. Similarly, if there are 4 inputs, how we are going to do it? We'll be having 2 select inputs. So in this case, A and B, if both are 0, 0, then I0. So A bar, B bar, I0 plus when this is 0 and this is 1, like A bar, B, I1, then when 1, 0, then A, B bar, I2 is the content. Then both are 1, 1. A, B, I3 is flowing there. So Z is equal to, this is the expression. Similarly, you can do it for 8:1 MUX or whatever the multiplexer you are designing. So now, one more thing will come. Why we require this multiplexer? We know what is a multiplexer, how it's been driving. So what input will be chosen as an output, it all decided by the control input. Then where we can make use of this multiplexer in the real time. So suppose if I have a multiple inputs and I need to drive only one at a time, like our TV remote control. So I'll be having multiple channels as being telecasted. So I'll be tuning to one particular channel. So that is how we can make use, or that is where we are using this multiplexer, or tuning your radio for particular channel. Realization of multiplexer is done using a basic gates. So here is the circuit for 8:1 multiplexer. So we all know what is the expression for this, right? We have already written an expression for the output Z, A bar I0 plus A I1. So here it's been written for the 8:1. So 3 select inputs. The select inputs are named as S0, S1 and S2. S2 is the most significant bit. Earlier example, it's been written as A, B, C. Now it is S2, S1 and S0. These are the inputs I0 to I7. There are 8 inputs. So these inputs are directly connected to this AND gates. So these 3 select inputs are deciding which AND gate will be enabled at a time. Any one of the AND gate will be enabled, that will be flowing across this OR gate. So the final output will be based on whatever that enabled AND gate, whatever the content, that's what we are going to get across this. Just have an example. So first AND gate is the content 1, rest all is 0, our output will be 1. If fourth AND gate is 1, rest all is 0, our output will be 1. So whatever the content across this, whichever the one is enabled, that's what we are going to get across our final output. So now, in order to make one out of this 8, how we are going to make that based on these select inputs. When all these 3 are 0, when all these 3 are 0, the output across this inverters will be 1, 1, 1, 1. If whatever your IN0, if IN0 is 0, I'm going to get 0 here. If IN0 is 1, I'm going to get 1 across this. So whatever the first output, AND gate output will be our final output. That is how it is working. If it is 1, 0, 1 means fifth AND gate to be enabled. So 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4 it is. This is our 5. So 1, 0, 1. If this is 1, directly it's been flowing here. This is 0. The output of this inverter will be 1. This is 0. This is 1. Directly it's flowing. So this AND gate will be enabled. Whatever our IN5 will be our final output. It all depends whether we are providing 0 here or 1 here. If you provide 0, we'll get that 0. If you provide 1 here, we'll get that 1. What if it is 1, 0, 0? 1, 0, 0 means it is 4. So it is I4. This AND gate will be enabled. You can just check out this. 1, directly it's been connected. 0, 0. Output of the inverter has been given for this AND gate in both the cases. So this AND gate will be enabled. So that's how this realization of any multiplexers will be done with the basic gates. All possible inputs across these AND gates in order to activate which particular AND gate to be enabled. And how many ever inputs, that many AND gates will be having. Then that outputs of the AND gates will be driven to the OR gate. So the number of inputs for the OR gate, final OR gate will be based on how many AND gates across the input. So here it is 8 input OR gate. If it is 4:1 multiplexer, then 4 input OR gate. If it is 2:1, 2 input OR gate. That's how you're going to realize the any multiplexer using the basic gates. Now we'll check out the demonstration of the multiplexers on the virtual labs. Go to this electronics and communications. In that hybrid electronics labs, then move on to this list of experiments. So in this list of experiments, I have already chosen this design and simulation of decoder, encoder, multiplexer and demultiplexer. Then click on this, click here for simulator. So this is, again we have all these. So now I'll be going for the multiplexer. So as and when we learn in the theory the other topics, we'll just go through those contents as well. So this multiplexer, here it's been given with D0 to D7. So 8 inputs. So 3 select inputs, 1 output. The circuit what we discussed, the same circuit has been given here. So now I'll just make this select input as 1, 0, 1. Then my output will be I5. I'll just run it. I'll get 1 across this. So I'll just make this off and run 0. I can just make all the rest on just to verify whether it will be working according to the concept what we have learned. Yes. Whenever this is 1, 0, 1, irrespective of any of the input is high or low, the content of I5 or D5 will be our output. So now I'll just do small changes over here. When triple one, if I just run, I don't know which output I'm getting here. It can be anything because all of these are high. I'll just make this off because when it is triple one, it is D7 to be our output. I'll just run again. Yes. Now I'll just make it off with D1. Let me make it on and run it. Yes, I'll just make this off. D1. If that should be my output, then it should be 0, 0, 1. You run that. Yes. You can just do it in a way however you want to work with multiplexer. Multiple inputs, single output. Based on the select inputs, it will be driving which input to be our output. This is how we can write the block diagram. So this is the multiplexer. These are the inputs. These are the select inputs. This is our output. So here it's been written for 8:1. So 8 inputs, 3 select inputs and 1 output. So with this, I'll end up the video of the concept multiplexer. But this multiplexer can be written like any number, like 2:1, 4:1, 8:1, 16:1, 32:1. So how we are going to do that? Number of AND gates. So if 16:1, 16 AND gates, 1 OR gate. That is how we'll be having. Then there are 16 AND gates. How many select inputs? 4 select inputs. So that is how this input and output ratio, input and select inputs ratio has been decided. 2 power n inputs, n select inputs and 1 output. So on this, you also have a lab experiment. So the next we'll be discussing how we can design for any given inputs and we have to realize using 8:1 multiplexer in the lab as well. So with this, I'll wind up this. Thank you.